In this presentation, we are going to cover Chapter 3.2, Adding Integers from the OpenStax Pre-Algebra textbook. Now, the learning objectives that we will cover in the video include modeling addition of integers, simplifying expressions with integers, evaluating variable expressions with integers, translating word phrases to algebraic expressions and then solving, and then adding integers and applications, so kind of word problem scenarios. All right, so let's first start by identifying two core integer rules that we can apply to both adding and subtracting of integers or negative numbers. So here are the two core rules that we will apply to adding and subtracting integers. Rule number one states adding a negative is the same as subtracting a positive. Now, to understand this a little bit better, let's apply this rule to the concept of money, because we deal with money every day. It's more tangible when we're looking at negative numbers here. So first off, let's start with the subtracting a positive part, as that's a little bit, I guess, simpler to kind of understand. It's something we do more often of, right? So let's say you have $200 in your bank account, and you go to lunch at a restaurant and you spend $20 of this, right? So you are subtracting positive value from the 200, right? So it's 200 minus a positive 20, and you end up with 180. So $180 is what you end up with at the end of that scenario. Now, subtracting a positive, subtracting a 20, can also be rewritten in the form of adding a negative. So let's say instead of you subtracting, taking a debit card out or cash, let's instead say you start with $200, but then you charge or add $20 to your credit card. In other words, you are adding $20 of overall debt to buy a product, right? In this case, you also end up with $180 at the end. In other words, rule number one type problems are decreasing the initial starting spot or the initial value that you begin with. Rule number two then increases your value. So subtracting a negative is the same as adding a positive. Let's again kind of apply it to a money scenario. So in this case, let's say you start with $200 in your bank account, and then you go to work and you earn $100 for that day. Okay, so in other words, you are adding $100 of income, of money to your bank account, and you end up with $300 at the end. Fairly straightforward, not rocket science, right? A little bit trickier though, something that we deal with, I guess on a less daily basis in a sense, is subtracting a negative. So subtracting a negative is the same as adding a positive. Let's say, again, you start with $200 in your bank account, but let's say you owe $100 to your crazy uncle Earl. Earl will be nice to you, he lent you $100, and then you have to pay him back. But then Earl decided, you know what, for Christmas or whatnot, or for your birthday, I'm going to eliminate that $100 of debt. So I'm taking away that negative value from you. In other words, you are subtracting a negative. You're subtracting away that debt. So we would say minus negative 100. This structure is the exact same as this over here. 200 minus negative 100 is also equal to 300. Now, often what happens if you see a subtracting of a negative, really you can simplify subtracting a negative down to just adding that positive form. So one of the things that you can do is you can just change this double sign immediately to addition if you want to. Okay, so 300 is where you end up. Let's apply those rules to the following sets of questions, and let's model those rules on a number line. So starting with question number one, we have positive 4 plus 3. Again, I like to think of it in terms of money. So let's say you start with positive $4, and then you are given, or you add $3 more to your overall bank account, right? So this is adding a positive. Adding a positive increases your overall value. So you are starting at 4 and then you're adding $3 or 3 units worth of value and you end up at a positive 7. In other words, this is a rule number 2 type problem, adding a positive. Let's look at question number 2 now. So question number 2 is -4 plus -3. In other words, you are starting with a negative and you're adding a negative value to it. So this is like charging a credit card. Adding a negative is the same as subtracting a positive. In other words, you are going to decrease your overall value. This is a rule number 1 type problem here. So if I go to my number line then, I'm starting at -4, and then I'm going back $3 or 3 units. And in this case, where I end up is at a -7. I'm going more negative, in other words. Okay. Question number 3 then is starting with a -4 and adding a positive 3. So this means you are increasing your value from -4. You're going to have more value than where you started. So in this case, I'm starting at -4 and I'm adding $3 or adding 3 units. So this is me going back 1, 2, and 3. So in this case, adding 3, you end up at a -1. Now, -1 is not quite positive, so we're not on the positive side of the number line, but you have gone closer to 0 now. Finally, question number 4, we start at +4 and we're adding a -3. So adding a negative is the same as subtracting a positive. You are decreasing your overall value. This is a rule number 1 type problem. So if I start at +4 and I'm going back $3 or 3 units, 1, 2, 3. So adding a -3 means that I'm going to end up at a +1 here. Okay, so that is my result. Okay, looking at a few more problems, but with some larger numbers, harder to model one by one on the number line, but we can still kind of visualize it using this structure. We'll start with question number 1 here. So question number 1 reads 20, so let's say again with money, $20, and then you add or you're charging debt to a credit card. You're adding a -57 or charging $57 to your credit card. This means you're decreasing your value and you're actually spending more money than you really truly have, right? So this is a rule number 1 type problem, adding a negative. So if I go to the number line, where I'm basically starting here is I'm starting, let's put a 0 here. I'm starting at $20 and then I am going back to the left on the number line a total of 57 units here, $57. So if I think about it this way, how many dollars does it take me to go from 20 to 0? Well, from 20 to 0, this is basically me spending 20 units, right? Well, how many dollars do I have left over from the 57? So I spent 57 in total. For me to go from 20 to 0 is 20. Well, this basically means I go back another $37, right? So where I end up here then is at a -37. So in other words, if I was to rewrite this, 20 plus a -57, and my answer becomes equal to -$37 here. So that is question number 1. Let's look at question 2. So question 2 is -15 plus 45, okay? So in this case, we start on the negative side of the number line, but we're now adding a positive 44. This is a rule number 2 problem. Subtracting a negative is the same as adding a positive. So I'm going to the right on the number line. If I go and model this then, I start at -15 on the number line. Let's put a 0 here. And then what I'm doing is I'm spending, or excuse me, not spending, I'm adding $45 to my bank account. So this is more than enough money then, or more than enough value to get me beyond the zero, right? Think about it like this. How many dollars does it take for me to go from negative 15 to zero? Well, it takes 15. And then what is the difference? Meaning if I was to essentially subtract 45 and 15, the difference between these two numbers, 45 and 15, is another 30, right? So where I end up here, if I add 45 to negative 15, I'm going to end up at a positive 30 here. Essentially what you're doing, because these are different sign numbers, a negative and a positive, you're finding the difference between those two numbers, subtracting them in effect. 45 minus 15 is 30. And since the bigger number is positive, positive 45, that is the final sign. You have a positive 30. Now, I didn't put a sign there. You might be asking, Chris, where's the sign? You could put a plus sign there, but really every number, its default form is positive. So that is really redundant information. It's extra information we don't need. So we can just write this as equal to 30. All right, let's look at question number 3 now. So question number 3 is negative 24 plus a negative 32. So in this case, I'm starting in the negatives. Put a 0 there. I'm starting in the negatives, negative 24, and I'm going more negative. I'm adding a negative $32, adding a negative. So in this case, I am never actually crossing 0, right? I'm staying on the negative side of the number line. So this is me actually adding these two numbers, 24 and 32. And because it's already on the negative side, my answer is going to stay negative. So if I think about it, 24 plus 32 is then 56 here. And it's in the negatives. So I end up at negative 56 as my result. Okay, so that's this question series. Let's look at another question series that's a little bit more complex because we're adding a series of questions here. Okay, so I actually should say more than one integer, not more than one question in a sense. So in this case, we have 5 plus negative 9 plus 7 here. So let's rewrite this. So there is multiple ways you could go about this, different strategies. So for example, we could group similar sign numbers. For example, 5 and 7, we could group that first. I like to initially, as we're first learning this, is to kind of keep it in order. So kind of think of it in terms of, okay, I'm going to solve two numbers at a time and then solve the next number after that and go from left to right. That's usually the easiest way to first understand this. And then from there, you can group similar sign numbers if you'd like. So if we look at this then, we have 5. I'm going to go to the number line here again. So we start with the number 5, and we're adding a negative 9. So this is adding a negative. This means we're decreasing its value here. So if I add a negative 9, where I end up here is at a negative 4. In other words, for me to go from 5 to 0, that's 5 total units. And then I have another 4 units to go out of this 9, right? So our first step here, if I do 5 plus a negative 9, I end up at a negative 4. So we now have negative 4 plus 7 here. Okay, so negative 4 plus 7. Now what I'm going to do is I'm going to go back to the right 7 units. So from negative 4 back 7 units means I end up at a positive 3, right? The reason it takes me 4 units to get back to 0, and then I have 3 units left over. So I end up at a positive 3 here. So this is equal to 3. That's your result. Now, the other strategy you could use with this is instead of doing it in order, let's say, for example, you notice that you have two positives here, the 5 and the 7. So instead, you rearrange your expression to put these next to each other. So 5 plus 7 plus a negative 9. And then you do the 5 plus 7 first, which is going to be 12 plus a negative 9. And then you have 12 plus a negative 9, which is really the same thing as 12 minus 9, essentially adding negative 9, same as subtracting a positive 9, and you end up at a positive 3. So that is another completely fine way of solving that type of problem. Let's look at question 2 now. So question 2, we have negative 18 plus a negative 6 plus 10. So in this case, the similar sign numbers are already grouped together. In other words, we have two negatives here and we're adding a negative, which means we're decreasing the value to start. So if I look at my number line here then, I'm starting at negative 18, and then I am adding a negative, which means I'm basically decreasing the value by 6 units. Now, this means I stay on the same side of the number line already. I'm already in the negatives, so I'm just making it more negative. I'm adding negative 6 to this, really. So here I am going to end up at a negative 24. So this first step here is going to be negative 24. And then I can drop down the 10. Okay, so now I'm at negative 24, and if I think about it in terms of money, I have negative $24, I'm in the hole, but then I add $10 back to it, so I'm increasing its value by 10. And where I end up here then is at a negative 14. Okay, so negative 24 plus 10 means I go back 10 units and I end up at negative 14. So that's question 2. Let's look at question 3. Some bigger numbers here now for question 3. We have 124 plus negative 95 plus 62. Okay, so in this case, we have a positive 124. Let's actually rewrite that. Let's put the 0 further because we're going to end up in the positive. So let's say I have a positive 124. But then I am going to add a negative 95, which is basically me subtracting $95 in value, or adding negative 95 to your credit card, if you think about it in terms of money. So I'm going back 95 units. All right, so where I end up here is at a positive 29. So this first set of numbers gives me positive 29, plus then the 62. So now I'm on the positive side of the number line. This is just a regular addition fact at this point, so don't overthink this one. We're going back now 62 units. Okay, and where I end up here, it's not really drawn a scale, but where I end up here then is about 91 units. We'll say about right here. Okay, so 29 plus 62 is going to be equal to 91 at this point in time. Okay. Okay, let's look at the last question series from simplifying expressions with integers. So some more complex ones here. So question 1, we have negative 5 plus a positive 18 plus a negative 7 plus 12. So again with this, there is multiple ways of attacking this. I'm going to go ahead and attack this first by just kind of going in order and 2 at a time. So if I start in that manner, we have negative 5 plus 18. In other words, I'm adding 18 units, positive 18. So this is adding a positive. I'm increasing in value. So if I start at negative 5, say this is the 0. If I start at negative 5 and I go back to the right 18 units, Basically, for me to go from -5 to 0 is 5 units, and then I have 13 more units left over. So I'm ending up at a positive 13 here. That's -5 plus 18 is positive 13. And then I'm adding -7 plus 12. Okay. So now I'm at 13, and I'm going to now add a -7. Adding a negative, same as subtracting a positive. Rule number 1 means I'm decreasing my value by 7 units. Okay. So where I end up here then is at a positive, still in the positives, but I end up at positive 6. So 13 plus a -7 is going to be positive 6 here, plus 12. So now I'm at positive 6, and I'm adding value. I'm adding 12 units, or adding $12 if I'm thinking about it in terms of money. So I'm going back to the right now by 12 units. And where I end up here then, 6 plus 12 is equal to 18. So my answer for this one is, oops, draw that incorrectly, is 18 here. Okay, so that is question number 1. Let's look at question 2. So question 2 has something that we need to complete in the parentheses first. So we have 21 plus 3, -4 plus 9. Okay, so in this case, we need to do what's inside the parentheses first. That's the -4 plus 9. So I start at -4, I then add 9 units. So if I go to my number line here, this is me adding 9. I'm going to end up at a positive 5 here. So now we have 21 plus 3 times positive 5. So I'm not going to need really the number line to model any more of this, unless I want to. But from here, I'm going to do 3 times 5. I'm going to do the multiplication step next. It's according to order of operations. Do the multiplication before addition. So 3 times 5 is 15. So I have 21 plus 15 now. And then 21 plus 15 is going to be 36 here. Okay. So question number 2 is equal to 36. Let's look at question 3. Something similar to the previous one. So we have 30 plus 2 parentheses -6 plus 11 here. So I'm going to first again start with the parentheses, -6 plus 11. So -6 plus 11 means I'm starting in the negatives. I'm going back to the right 11 units. It takes me 6 units to get to 0, and then I have 5 more units after that. So 5 is my answer for -6 plus 11. So rewriting this, I have 30 plus 2 times 5. 2 times 5 then is 10. So I can write this as 30 plus 10. And then 30 plus 10 is equal to 40. Okay. So this ends our series on simplifying expressions with integers. The next learning objective is to evaluate variable expressions with integers. So in this case, you're given an expression, x plus 10, and then you're asked to solve this expression when x equals -19. So this is a process then of substitution where you take the now known numerical value, -19, and you substitute it into the x variable of the expression. So this now becomes -19. I've replaced the x variable plus a number 10. From here, we're following the same process that we did in the previous problems where we simplified expressions. So in this case, we start at -19 on the negative side of the number line. We're then adding a positive, adding positive 10, That's increasing our value. So we go back to the right on the number line. We're going back 10 units. This isn't enough to cross over into the positives though. I can't cross over 0. Where I end up here then is at -9. So my answer for question number 1 is -9. Looking at question 2, kind of switch the order of the structure. It says when x equals -12, evaluate x plus 5, but it's still giving me the expression x plus 5, and then asking me to solve when x is equal to -12. So what we're going to do is we're going to substitute -12 into x. So this becomes -12 plus 5. And then from here, we're going to simplify this expression. So we're at -12. We're then adding 5 units. And I end up at a -7 here. Okay, so -7 is my result for question number 2. Sorry. Question number 3 then, evaluate the expression 2x plus y when x equals 15 and when y equals -20. So I'm going to now replace the x equals 15. I'm going to substitute the 15 into the x variable. So it would now read as 2 times 15 plus the y variable of -20, or the number for the y variable, -20. So I like to show substitution with a parentheses, so that's why we're doing the -20. So now we have 2 times 15, which is 30, plus a -20. So here we are adding a -20. This is the same as subtracting a positive. So in this case, I'm going back 20 units. So if I think about this on the number line, I start at 30. I then am going back 20 units. Now this is not enough to cross the 0 into the negatives, right? We're still on the positive side of the number line, but where I end up is at a positive 10 here. Okay, so positive 10 is our result. In the chapter reading, you will also come across problems that asks you to translate word phrases to algebraic expressions and then simplify those expressions. So starting with question 1, we have translate and simplify the sum of -10 and 6. So the sum is another word for add. So we are going to, in other words, add -10 plus the number 6. So this is the expression from this word phrase, -10 plus 6. So then going to my number line, I'm at -10. I then am adding a positive 6. So this means I'm increasing my value, but 6 is not enough to go from -10 into the positives, right? So where I end up here then, if I go back 6 units, is at a -4. So -10 plus 6 gives me a -4 here. Question 2. The sum of 7 and -15 increased by 2. So again, the sum is add. Increased by is also addition. So you have 3 integers that you're adding together. You're adding together 7 plus -15, and then you're also increasing this by another 2. So adding another 2 here. So 7 plus -15. What's interesting about this though is if I start at 7 and I add -15 to this, this means I'm actually going back to the right on the number line, or excuse me, back to the left on the number line, 15 units. So where I end up after doing this is at a -8 here. So I end up at -8 for this first two integers, I should say. So now I have negative 8 plus 2. So negative 8 plus 2, adding 2 more units, means I go back to the right then. I'm increasing by 2. So where I end up here then is at a negative 6. So negative 8 plus 2 gives you a negative 6 as your result here. Looking at question number 3 now, we have translate and simplify the sum, meaning to add, of 9 and negative 18, and then increased by, again, adding 10. So I have the sum of 9 plus a negative 18 increased by 10 more units. So if I go to my number line, I start at positive 9. I then am adding a negative 18 units, which is essentially the same as subtracting a positive. Adding a negative is the same as subtracting a positive. I'm decreasing my overall value. So 9 plus a negative 18 means that I'm going to end up back at negative 9 here. Okay, so the first two integers, negative 9 is my result. From here then, and this isn't drawn to scale on the number line honestly, but from here I'm going to add 10 units. So this means I'm going back to the right 10 units here. So plus 10. And where I then end up is at a positive 1. Okay, so negative 9 plus 10 gives me a positive 1 as my result. Okay, so that is a few problems on translating word phrases to algebraic expressions. Let's now look at the final concept from the chapter reading, which is to add integers from applications or in applications, so word problems essentially. So question 1 here, we have Tom owes $100 on his credit card. So to owe something means you're in debt. So where we're starting, or where Tom's starting, is at a negative 100. He then charges, so he adds $20 more of debt to his credit card. So in this case, he is adding a negative 20. It then asks, what is his new balance? So we are essentially doing negative 100 plus a negative 20, which means you are decreasing in value by $20. You're going more into the negatives. So if I add $20 more in debt, where I end up at is at negative 120. So that's question number 1. Question number 2 reads, Tim is down $50 in his bank account. He then gets a paycheck for $225 and deposits into his account. What is his new, little typo there, what is his new balance? So again, Tim is starting $50 in the hole, but in this case, he gets a paycheck. That's income. That's increasing his value. So we're going back to the right, $225 or 225 units. So if I model this on my number line then, I'm at negative 50. I then am adding $225 in total. So if I kind of break this number up then, for me to go from negative 50 to 0, that's 50 units or $50 in total that I have to add. You then have, if you were to find the difference between 50 and 225, that's another $175 that you can go. So where he then ends up is at a positive 175. Okay, and that is your result. Okay, so again, in this presentation, we covered the following learning objectives that you can find in chapter 3.2, adding integers. So we looked at modeling addition of integers on a number line, and we did that repeatedly on all the problems, basically. We then looked at simplifying expressions with integers, evaluating variable expressions with integers where we substitute a known value into the variable and solve it. We translated word phrases to algebraic expressions, like translating the sum of negative 6 and 10, for example. And then we looked at a few word problems as well. So at this point, I'd go ahead and get back in the textbook chapter, which the textbook chapter you're looking at is chapter 3.2, adding integers. I'd go ahead and you can look through the other ways. So in the textbook chapter, by the way, it does give a slightly different way of modeling. So it uses integer chips. I tend not to like that as much. So I use the number lines, but you can take a look at the textbook and reach out to me if you do have questions on that method. And then you can go down and you can solve the different questions down here. So get some more repetition within the textbook. And that will be in the description for the video, the direct link to the textbook. If you do have any questions from that, feel free to reach out. Happy to provide some more videos from that. Otherwise, good luck everyone, and I'll see you in the next video.